Alright, let's finish off with a little discussion on the other concept of this lesson, which is determinants. So, the determinant of a square matrix helps us determine whether an inverse exists for that matrix. So if the matrix is square, then a determinant might exist, but we need to check whether the determinant is equal to 0. If it is equal to 0, well then the matrix does not have an inverse, and it is known as a singular matrix. It's non-invertible, it has no inverse. And we have a nice little formula for a 2 by 2 matrix. If it's A, B, C, D, we've already seen this. It was in the denominator of our inverse formula. It's AD, we'll multiply in that direction, minus BC. Now, there actually is also an algebraic way of finding the determinant of a 3 by 3 matrix, which maybe I'll show you quickly. So suppose you got ABC, DEF, GHI, and that's your 3 by 3 matrix. A clever way of doing this is to add the initial two columns again, A, D, G, B, E, H. And so the determinant of this matrix would be found by doing, remember how this one we said this one minus this one? Okay, now we're going to do this one plus this one plus this one minus this one minus this one minus this one. So the products that go down from left to right, these are all positive products. So AEI, BFG, CDH. But then we're going to subtract the ones coming in this direction. CEG, AFH, and BDI. And then, of course, we would just substitute and evaluate. So it is possible to do a 3 by 3 determinant by hand. But to be honest, we're going to give you a calculator when you're doing 3 by 3 or bigger determinants anyway. So you'll have to do a 2 by 2 by hand on a test. But 3 by 3, yeah, we'll let you use a calculator. So let's use a calculator to find. Well, we'll do the calculator for the 3 by 3, shall we? Let's just find the determinant of this this particular 2 by 2. So the determinant of A, which, by the way, you could also notate as kind of like the absolute value of A, because the determinant of A, you can think of it like a magnitude. Not like a magnitude as in a distance on a number line, but it's kind of a way of sort of interpreting, I suppose, I don't really know how to say this. I guess we're consolidating all of the numbers in the matrix into a single value. And this value, the determinant, if it equals 0, well then we're not going to be able to find the inverse. I mean, imagine if our determinant was 0, then look at our formula for the inverse. If this determinant was 0, we'd have 1 over 0 times the switched entries. And of course, we can't divide by 0. So that's kind of shows us that if the determinant is 0, we've got no inverse. So the determinant of A, this is a 2 by 2. Let's do it by hand. 5 times negative 4 minus 2 times negative 10. And that gives us negative 20 plus 20 equals 0. Aha! Well, this must mean then that A inverse does not exist because we got a 0 determinant. Or if you like, you could say, therefore, A is non-invertible. Or you could say A is singular. Okay, so 3 different ways to describe this idea, thanks to our determinant giving us that clue. Let's do part B with a calculator. And so I'm going to have to enter a brand new matrix. So I'll go into the matrix feature. And I could write over matrix A, but let's just create a brand new matrix called, and we'll edit it, matrix B. And it's going to be a 3 by 3 matrix. And it's got entries 3, negative 2, 5, and then 0, 1, 4, and then negative 1, 0, 2. Press enter after the last entry to ensure it has been recorded. And now I'm going to quit. And I want to find the determinant of this new matrix I just created, B. To find the determinant, I'll again go into the matrix feature, and I'll go into the second menu, Math. And you can see that option 1, that's the determinant. So let's hit enter while it's selected. We're looking for the determinant of the matrix whose name is A. So every time that you want an A or a B or one of the matrices to actually appear on your screen while you're doing a matrix calculation, you're going to go into the name menu, and we want to go to the matrix that is named B. And what do we get? 19. So the determinant of B is equal to 19. What does this tell you? Well, because it's not 0, then the matrix inverse does exist. And so that must mean that matrix B is invertible. It is not singular. Okay?